So in this next video, we're going to talk about domain, holes, discontinuities, and vertical asymptotes of rational functions, because those all deal with the denominator. They deal with examining the denominator. All right, so we've been talking about domain a lot. Domain are the values that make the denominator undefined. And we've said when we're dealing with rational functions, we always want to look at it in factored form before we start making any decisions. So this one is given to us in factored form. X plus 3 over x plus 2 times x minus 1. So in this case, we know the domain are the values that are going to make the denominator 0. And the values that would make the denominator 0 here, we can see that x is not allowed to equal -2 or +1. So my domain in interval notation is that x is in the set from -∞ to -2, union -2 to 1, union 1 to +∞. Because we don't have any factors that cancel, this rational function does not have a hole. So that means that both of those discontinuities, the breaks in the graph, the undefined values that are coming from the denominator, both of those represent vertical asymptotes. So we have two vertical asymptotes here. X equals -2 and x equals +1. So let's look at another example here. I'm going to give us this one in factored form as well. F of x equals x plus 3 over x minus 7 x plus 3. All right, so domain is going to come from determining the two values that would make the denominator undefined. So for my domain here, I know that x cannot equal +7 or -3. So if I were to write my domain in interval notation, I would say -∞ to -3, union -3 to 7, union 7 to +∞. Okay, so in this situation, you'll notice we have a factor x plus 3 in the numerator, because that's all grouped together, and an x plus 3 in the denominator. And I can reduce that out. So my function, I have a reduced version of my function here. F of x equals 1 over x minus 7. So that's my reduced version. So since I canceled the factor x plus 3, that means we have a hole at x equals -3. Now, if I want to find the ordered pair for that hole, I need to plug -3 into the function. The issue is I can't plug -3 into my original function because I would get 0 in the denominator. So we have to plug -3 into the reduced version. So when I do that, I have f of -3 is 1 over -3 minus 7, or 1 over -10. So my hole is -3, -1/10. So that means the piece that was left, my undefined value that was left, x minus 7, that is my vertical asymptote. And so my vertical asymptote, it is the equation of a vertical line, is going to be x equals 7. So if we're looking for our answers, we have the interval for the domain. We have the ordered pair of where our hole would occur, and the equation of an invisible vertical line, which represents our vertical asymptote. So I have another example for us here. This one is not written in factored form. So the first thing we do is we always want to consider our functions, our rational functions, as factors, right? So in the numerator, I can factor out a GCF of x, which leaves me with x minus 2. And my denominator is a difference of squares. X plus 2, x minus 2. So when I go to start thinking about my domain, I know, since there are 2 factors in the denominator, that there are 2 values I have to omit from the domain. In this situation, x cannot equal -2 or +2. So the domain of this rational function is that x is in the set from -infinity to -2, union -2 to +2, union 2 to +infinity. So then we go and think about our hole, and the hole comes from any factor that cancels. So if we have a common factor in the numerator and the denominator, we can reduce those out. So because x minus 2 cancels, that means there is a hole at x equals +2. So once I cancel that, that creates a reduced version. I have my function is now equal to x over x plus 2. So if I want to find the ordered pair for my hole, I'm going to plug x equals 2 into the reduced version. So that means f of x equals 2 over 2 plus 2, or 2 over 4, and that should say f of 2 in there. So f of 2 I plugged into, I get out 2 over 4, or 1/2. So at this point I know there is a hole at +2, 1/2. And so then the factor that is left in the denominator, that is my vertical asymptote. So my vertical asymptote occurs at x equals -2. And again, the notation is important here. We need to write that as a vertical line. So we have domain, we have a hole, and we have a vertical asymptote.